Hello viewers, this is Dr. Naina Khullar, Assistant Professor, Department of Zoology, Gujri College, Fatehgarh, Sahib. I welcome you to the practical video lecture series on study of the effect of temperature on activity of salivary amylase on starch, part 2. The aim of this experiment would be to study the effect of different temperatures on the activity of salivary content, that is, amylase or ptyalin on starch. The learning outcomes would be students would be able to understand how change in temperature can delay the process of digestion, and the requirements for this experiment would be 3 test tubes, iodine solution, ice cubes in water, 15 milliliters of 1% starch solution, 3 milliliters of 0.9 sodium chloride solution, saliva solution, droppers, thermometer, Bunsen burner with wire gauze. Before we start the experiment, we need to have a short recap, and I would request the viewers to first go through the part 1 to understand and have the basis of the concept, how and why starch gives blue color with iodine. Let's take up the effect of temperature now. Amylase show attenuated activity at low temperature, and second is that amylase gets denatured at high temperature since it's a protein. Keeping these two facts in view, let's study the effect of temperature on the activity of salivary amylase on starch with an experiment in the laboratory. Take a beaker containing 15 milliliters of 1% starch solution and add 3 milliliters of 1% sodium chloride solution in it. Second, we need to divide and pour this solution into 3 test tubes. Mark these test tubes as A, B, and C. Maintain the temperature of the beaker containing ice cubes at 5 degrees Celsius, and we must pre-prepare ourselves with this fact. Take another 2 beakers containing water and heat over the Bunsen burner. Now transfer the experimental tube A into the beaker containing ice, while the second particular tube B should be transferred into water bath at temperature 37 degrees Celsius. And in the third tube C should be placed in the beaker which is maintained at a temperature 50 degrees Celsius. Therefore, we have a setup of 3 test tubes, test tube A at lower temperature, test tube B at optimum room temperature, while test tube C is placed at a higher temperature, that is 50 degrees Celsius. By this, using a dropper, take 1 milliliter of each saliva solution and transfer the solution into test tube A, B, and C. Now keep the 3 test tubes undisturbed for 3 to 4 minutes and let the salivary amylase digest the starch. After an interval of 3 to 4 minutes, add a few drops of iodine solution in each test tube A, B, and C. Test tube A, color turns blue. In test tube B, no change, while in test tube C, the color turns blue. Result: it takes less time to reach the achromic point at 37 degrees Celsius because the enzyme is maximum active at this temperature. While at higher temperature and lower temperatures, more time is taken to reach the achromic point. This completely shows that the specificity of the enzyme amylase is definitely linked to the temperature. Conclusion: all enzymes are proteinaceous in nature, and at lower temperature, the enzyme salivary amylase is deactivated temporarily, while at high temperatures, the enzyme gets denatured. Therefore, more time will be taken by the enzyme to digest the starch at lower and higher temperatures. and at optimum 37 degrees Celsius room temperature, the enzyme is most active and hence digests the starch into maltose. With this, I hope you have been able to assimilate how temperature affects the activity of a proteinaceous enzyme known as salivary amylase, and the lecture was lucrative to you. Thank you.